So I hope it's recording. Should be recording. Welcome to section 1.2. You've survived your first day. So today we're going to talk about different kinds of numbers, and it's not going to make too much sense because when we talk about these different kinds of numbers, we're going to talk about all sorts of kinds of numbers, and then I'm going to turn around and do problems that aren't really from what we talk about, but it's because I need the background of what we're talking about in order to do some of the problems. So I'm going to go ahead and give you some background. If I were you, I would write this down. I'm not saying that it's going to be on a test. I'm not saying that it's going to be something that you have to do a lot of or that you have to grasp completely now, but it is stuff that eventually will get built upon. It's kind of like the way they do fractions, how they give you a little bit of fractions and they give you a little bit more and they give you a little bit more. Well, this is the first little bit, and it'll get repeated eventually in probably every class I teach you. So think of it as a good foundation kind of thing. So we're going to talk about different kinds of numbers. The first kind of number we're going to talk about is natural numbers. Natural numbers are numbers that appear in nature. For example, you can count on your fingers and toes 1, 2, 3, so forth and so on. Those are natural numbers. If you want to talk about numbers that are not natural, our next set of numbers is whole numbers. So these are all natural numbers, but whole numbers encompass not only all of those natural numbers, but it also adds 0. 0 is a whole number. I want to see something real quick. I wanted to see what it would look like with that off, if I would get more usage. So we're going to play with lights for a second. I really don't like the shadow though. Just a second. Let's see. That may be better, may not be better. We'll find out in a minute. So in addition to whole numbers, you can have something called integers. Integers are all your whole numbers, all your natural numbers, and their opposites. So you end up with -3, -2, -1, 0, 1, 2, and 3. All of those. So integers are everything that whole numbers are, everything that natural numbers are, plus more. All their opposites. ... Then there's even more. We have something called rational numbers. Rational numbers are all the integers, all the whole numbers, all the natural numbers, all the numbers 1, 2, and 3. But rational numbers, more importantly, are any number that can be written as a fraction. So it includes all the fractions, all the decimals. if they end or repeat. So we've had a discussion before about 1/3 and how 1/3 written as a decimal is 0.333333 repeating, and that means that it's going to keep on going forever and ever is that 0.333. But, comma, that 1/3, because it repeats, that makes it rational, which is good because 1/3 we already know is a fraction. So it has that repeating nature to it. There are some decimals that just end, like 4.57692. It ends after the 2. There's nothing else behind it. But then there are some numbers that are not rational numbers. They keep on going forever and ever and ever. They're called irrational numbers. An example of an irrational number that keeps on going forever and ever is any decimal that ends in a ... That ... tells you it's going to keep on going and going and going and going. And we don't know what those ... are, but it keeps on going forever and ever. Another example might be something like the square root of 2. If you were to put the square root of 2 into a calculator, it's going to give you 1.4 and then some other numbers behind it. That's the whole ... Now your calculator will round it off, but because there are so many numbers behind it, it keeps on going forever and ever and ever. Another one is the square root of 3. But the square root of 4 is not irrational. The square root of 4 isn't irrational because the square root of 4 is actually equal to 2. So not only is the square root of 4 rational, the square root of 4 is also an integer, it's also a whole number, it's also a natural number, because you know that 2 falls into all of those. So not all square roots are irrational. Just the ones that you can't take are irrational. If you can take the square root of it, then it's a rational number. We don't necessarily write that rational number, but it's a rational number. Another type of irrational numbers are pi. You've seen pi before. Pi is that lovely number that's 3.14 ... They don't always tell you to use the ... They also tell you can approximate it with 22/7. That's an approximation, just like our 3.14 is an approximation. It's not an exact value. We can't get an exact value because it keeps on going forever and ever and ever. So we're kind of stuck with this. If a number is irrational, then it is not rational. It does not encompass all of those other numbers. I've been drawing all these boxes around this natural number stuff. This one is one box that is not included in all of that natural number stuff. It's either rational or it's irrational. It cannot be both. Only women are allowed to be both. Your mom and dad will think it's funny. So, all of these numbers fall into the same category. Whether it's rational or irrational, all of them are considered real. Now I know you're thinking, then all the numbers in the world are real numbers. That's not true. When we get to Algebra 2, we're going to talk about some numbers that are not real numbers. They're imaginary numbers. I know you think I'm making it up, but really I'm not. Your mom will tell you I'm telling the truth. They're imaginary numbers, and we will talk about those when we get into Algebra 2, but for right now, all the numbers that you're going to deal with are going to be real numbers. So, let's talk about the number line. Where's my eye eraser? Where's this one? If you're flipping out because you couldn't get all that written down, you can always go back and watch it again. It's nothing stressful. Like I said, you're probably not going to see it very much. It's not a big deal. So, when we have a number line, we have all of our positive numbers on this side, and we have all of our negative numbers on this side of 0. 0 is right here. And technically 0 is neither positive or negative. But what we have to understand is, in this great number line, where does everything else fall in? So if I have 1 over here, and I have negative 1 over here, where is 1/2 going to be? Well, 1/2 is located halfway in between, because we know 1/2 is positive. So 1/2 is located there. Where would negative 1 and 1/2 be? Everybody wants to say that negative 1 is here, so negative 1 and 1/2 would be here. But remember, we're going in a negative direction, 1 whole plus another half. So we still got to go in that negative direction. So negative 1 and 1/2 would be here, or negative 1.5, either way. Just like this is a positive 0.5. Doesn't matter which way you write it. So when we look in our book, on page 10, they want you to give the coordinate of each point. So if you look, problem number 1 says C. They want to know where C is. Up above is the number line. So C on that number line is located at what number? And I bet you said negative 1.0, because that's what it is. And for problem number 2, they want to know where E is, and I bet you'd say it's at negative 0.5. Number 3, they want to know where H is. H is different, because H doesn't have a number written right there by it. So when I look at my number line, it says this is 0, and over here it has a 0.5, and it's got 1, 2, 3, 4, 5 little marks. So 1, 2, 3, 4, 5 little marks. And my second mark is where our H is that we need to find out. So if it takes 5 little marks to get to here, this mark must be at 0.2. Because this little mark is going to end up being 0.1, and this little mark is going to end up being 0.3, and this little mark is going to end up being 0.4. Because they're equal distances in between them. So you need to be able to split up those marks just like if they were fractions. And you split those up into equal parts. So for number 4, J, what do you think that one is? 0.8. And for number 5, B, what do you think that one is? Negative 1.2. D is negative 0.8. L is a positive 1.2, and N must be a positive 1.6. If you have questions on those, make sure you ask your mom, like now. Pause the tape, go find her, drag her up out of bed, whatever it takes. Ask her about those if you have a question about them. Problem number 10. I think I was actually on the previous page for that. State the letter of each coordinate. So for number 10, the letter that they use was a K. So that took care of problem number 10. Problem number 18. They want us to show that this number is a rational number, and they give you the number -5. Once again, in order for something to be a rational number, it has to be able to be written as a fraction. So they want us to show them how to write this as a fraction. So if I want to write -5 as a fraction, there are tons of ways I could do that, but the easiest way to do that is to just go ahead and stick a 1 underneath it. So it would be -5 over 1. The next one is number 20. Which is 2.618. They want us to show that this is rational. So in order for us to show that it's rational, once again, we have to show that it can be written as a fraction. So if I wanted to write this as a fraction, we know that this is our whole part, and this part is the fractional part. So if I write this as a fraction, I can just stick the 2 in front of it. So 618 over, this time it's going to have to be over 1,000, because that's in the thousandths, tenths, hundredths, thousandths spot. And I can reduce 6 1/8. 2 goes into 618 309 times, and 2 goes into that 500 times. So my fraction for this particular number is going to be 2 and 309 over 500. Now, this may not be what they have in the back of the book. They might have been okay with it being 2 and 618 1,000ths. They might have been okay with it being written like this. They might have written it as an improper fraction. All of those things work. All you have to do is write it as a fraction. You cannot, however, write 2.618 over 1, because that has a decimal in it. You can't mix decimals and fractions. That's not good form. So don't try to do that one. Number 22. They want us to show that -6 and 5 over 6 is rational. In order for it to be rational, it has to be written as a fraction. Technically, they don't want it to have a whole number. I just noticed that in my notes. So if they don't want a whole number here, I could just put the 2 in front of this up here and have 2618 over 1,000, and I've gotten it. Or here, I can multiply it out. 5 times 2 is 1,000 plus that. So that would give me 1309 over 500. Down here, they want it written as an improper fraction. So 6 times 6 is 36. Plus my 5 over 6. The negative stays out front. So that gives me a -41 over 6. And that's my improper fraction. For number 24, I think I can squeeze it down here. They want us to write 0 as a fraction. 0 over 1, that's your fraction. That's as much of a fraction as you get for it. Now, this has been a shorter video than your last video, and that's excellent thing. I'm glad that it's shorter. However, you still have classwork and you still have homework. The only difference is this time your classwork is your homework. So once you're done with your classwork, you can actually check yours yourself this time. Your classwork / homework this time is page 10. Numbers 1 through 29, odd. You'll be able to check it yourself. You won't have to bother your mom. The only thing you need to do is make sure that you write in whichever section of your notebook that you put this, and the other section of your notebook. So if you leave this in your classwork section, in your homework section, you need to write down that it's in the classwork section. And if you put it in the homework section instead, you need to write down in the classwork section that it's in the homework section, so that your mom will be able to find it when she's grading stuff. I will talk to you later. Love you. Bye.